Hello everyone. So welcome to this lecture on IAC and CM. IAC is infrastructure as code, CM is configuration management in DevOps. Okay. So in the previous lecture, I already talked about CI/CD. CI/CD is a core aspect of DevOps. And now we're going to look at two other components that complement CI/CD. So infrastructure as code basically is the process of managing and provisioning IT infrastructure through special configuration files or modules rather than actually doing physical configuration or using a UI console to do configuration. Okay, so what are the IT infrastructure that we are interested in and where do we use them in? So IT infrastructure can be actual physical server, we call these bare metal servers. They can be networking stuff like firewalls, routers. They can be virtual machines on a public cloud provider. If you don't know what a virtual machine is, I'm going to explain this to you later on in the lecture on Docker. Okay, so if you have never used a cloud before, cloud basically runs on virtual machines, and if you're using a public cloud provider like Azure or Google Cloud Platform or AWS, okay, that's also a form of infrastructure. Docker is also a form of IT infrastructure as well. So all this infrastructure has to be set up in all phases of a CI/CD pipeline. So you will have one server whose primary purpose is just to do compilation of your code. And you might be thinking, why is that the case? I mean, compiling code is very simple. It depends what kind of code you're compiling, because sometimes when you compile code, you need to have a lot of dependencies, okay, for your code to run. And these dependencies is usually library files which need to be downloaded, and they need to be confirmed, and they need to be validated. So the build process can be very simple or it can be very complicated. Depends on the application you are building or you're compiling. So this requires sometimes a build server to do. And then of course we talk about the staging environment, which is to replicate the production server itself for the purpose of testing. And then of course you have the final production server itself. So you need IT infrastructure for all these things here. And the question is, how do you set up, how do you manage and set up, or how do you provision all this IT infrastructure? Well, the traditional way of doing it is, well, there's the physical setup of the IT infrastructure, which is maybe 20 years ago, this is what you want to do. Your company will buy a physical server, they'll put it somewhere, then somebody will come in there, somebody will install Windows Server, or somebody will install Linux, Ubuntu or Red Hat Enterprise Linux or CentOS or Fedora or some other Linux distro. Then they will go ahead, configure everything, set up the operating system, configure the networking, blah blah blah. All of that, that's physical setup. That's really outdated. Nobody does this anymore. Okay, then you have, of course, cloud. That's what most people are doing now. Everybody's moving to the cloud. So on the cloud, you have what is called a virtual machine. So you have, like, for example, on Amazon, you have something called an AMI, Amazon Machine Instance. This is a template. From this template, I can launch multiple EC2 instances, which are actually virtual machines, and they are going to run on these different physical servers here. So these physical servers here, which are in the in Amazon's data center, they're just going to be basically running all these virtual machines or EC2 instances. So for this case, you won't actually have the system administrator walking around to all these servers, okay, because there are literally millions of these servers in a data center. So you're not going to do this kind of approach in a data center. But when you provision your infra on the cloud, you generally are going to have a console like this. So later on in the lab session, you're going to see how I provision a bunch of EC2 instances as VMs through a console UI like this. I'm going to go to the console, click here, set up the instance, and then the instance is running. Then I can connect to the instance using SSH or some other client. Okay, so this is basically how you do stuff. And if you are only going to provision some basic IT infrastructure, like you're only going to set up one server, or you're only going to set up 2 or 3 EC2 instances, it's not that difficult to use a console UI, right? With the console UI, I only need to take about 3 minutes to configure a VM. Okay, so it's not that long, it's not that difficult. The problem comes when you talk about complex infrastructure. So let's say you're deploying an app that's going to be used by 10 million users. Okay, like you're working in Uber or TikTok. you know, or some super large software company, and you have hundreds and millions of users for your app. So hundreds and millions of users for your app, you can't deploy your app on one single server. You know, one single server cannot handle the load from 100 million users. So your infra is going to be quite complicated. You're going to have multiple servers, you're going to have load balancing, you're going to have firewalls, and blah blah blah. Now, if you're going to set this up by just going to here and click, you can be click for 3 hours in order to configure, I don't know, maybe 50 servers, 100 servers. Each of the servers might be running different operating systems. You have to configure, you know, the subnet settings inside that server, blah blah blah. A lot of settings yet. You just literally have to sit at the UI for the next 3 hours and click. Okay, now that's fine if you can do that. Then you have to remember what you click, what are the numbers you type in, what are the parameters you type in for all the 30 to 40 instances that you manually created during a console, using the console UI. So that is obviously not good, because then the next person who takes over from you have to ask you, hey, what to click, how many times do I need to do it? So very, very confusing. And this is where infrastructure as code comes in. So with infrastructure as code, you actually write a special configuration file that looks like code. That's why it's called infrastructure as code. So this configuration file, it has the content of it, looks like a programming language, it looks like code, but this code tells you or tells the system how to set up the IT infrastructure. Okay, so when you have IAC running, it's going to look something like this. So you are the developer, you're going to write the code. Okay, so this is not your standard C#, Java, C++, Python code. This is a slightly different structure. You'll see a bit like this later on when we work with Ansible in the lab. So this is basically infrastructure as code. You're going to have a file like this, and this file you're going to commit to your Git repository as well to do version control on it, and then you're going to push it to a automation server like a CI server like Jenkins, and then it's going to automatically spin up all the virtual machines either in the public cloud, so in AWS or Azure or GCP, or let's say your company has their own private cloud, on-premises infra. Okay, you'll spin up all those instances there as well. Okay, just from this one single file. Okay, so now you don't have to spend hours and hours clicking on the UI. You just write this code and then you send it to the automation server, and then the automation server will then run it to spin up all these VM instances. Okay, so these are the benefits. Okay, one is the configuration files are easier to edit and distribute. So like once I've created this file, I can give it to other people in my team. They can do the same thing again, right? So it's very easy. It also, most importantly, it ensures consistent provisioning of the exact infra environment every time. So let's say I want to set up an infra environment for my production server. So maybe my production environment, I need to have 20 different servers, 10 of them need to use Ubuntu, 5 of them need to use Windows Server, another 5 of them need to use Red Hat Enterprise Linux or Fedora, okay, something like that. And I need to set up all these servers in different ways. All of that configuration I can do in one single file here, and then I just use that single file to set up my production environment every time I need to. So I don't have to waste my time manually doing it over and over again. And I will always get the same environment every time because I'm using exactly the same configuration file to provision the environment. Okay, and this is so important, because the biggest problem in a CI/CD pipeline is what we call environment drift. Okay, what is environment drift? Okay, so we go back here to my original CI/CD pipeline. Okay, so if you have your my CD pipeline. Okay, so the environment drift is like this. Okay, so let's say you have a bunch of servers that you use to do your build on. You have a bunch of servers that you use to do your testing on, or your staging process on, and you have a bunch of servers that you use to do your production on. Okay, the problem is how do you ensure that the servers you're doing your testing on are exactly the same as the servers you are running your code on, your production servers? Okay, now this is very important because there is no point on testing your code on this one server if you're going to run it in a slightly different server environment. So let's say if I test my code on a server that's running Windows Server 2016 and running Java 8, and my production server is running Windows Server 2022 and it's running Java 11, you might think, yeah, latest version, so what? Sure work one, right? No problem. If it works on Java 8, it must work on Java 11. If it works on .NET Core 3, it must work on .NET Core 6. True or not? No, not true. Different version, just one number off on the version, your code that was previously working nicely on the previous version may not work on the next version up. So that means that your environment here must be exactly the same as your production environment. Otherwise, your testing is all completely wasted. There's no point of doing the testing because you can pass all the tests here and it can still crash on the production server. So how do I make sure I have exactly the same operating system, the same Java version, the same .NET Core version, the same C# version, the same port number, the same domain name, the blah blah blah? How do I make sure it's exactly identical? Okay, that is where IAC comes in, right? Because IAC, you with one single configuration file, you make sure that you always get the same infra every single time. So you're going to get the same infra for your staging environment, you're going to get the same infra for your testing environment, you're going to get the same infra for your production environment. So that guarantees that if your code passes all the tests in the staging or testing environment, then they are guaranteed 100% to work on the production environment. Okay, because you don't have environment drift. Okay. Then the other things about IAC is you don't have undocumented ad hoc configuration changes. And the reason why you don't have that is because you're going to commit your IAC file to a version control system. So that means if developer A decides to change even one single setting, okay, developer A decides to change one single setting, want to change the port number for my MySQL database on this Linux server. You just make that one change, that has to be committed to version control, and then we can know who is the developer that made the change to that configuration. Okay, if you don't have a version control, then anybody can make a change to this file, which means that the infra configuration can just change and we have no idea. Like, how come the previous time I set up this infra, the database is running on port 8080, and now I set up the infra using this file, now it's running on port 1990. Who is the smart ass who changed from 8080 to 1990? Well, if I don't have a version control system, I won't know who is the smart ass who did that, right? So therefore, with the IAC that you're committing to version control, you will avoid all these undocumented ad hoc configuration changes. Okay, so IAC is a very important part of CI/CD pipeline. It applies all the best practices from DevOps to management. So IAC provisioning is usually fully automated because all you need to do is you just take this file, send it to your automation server, so to Jenkins, for example, and Jenkins will automatically spin up everything that is required. So that's very nice. And it's also triggered in the CI/CD pipeline after a particular phase is complete. So that means right now, let's go back to your CI/CD pipeline. So let's say after your build phase is complete, everything is fine. Then you need to do all this staging and testing, right? So automatically when this build is completed on the CI server, the CI server will automatically run the IAC file. It will automatically spin up all the virtual machines or the Docker containers that are required to do all the staging and testing. And then when this has completed, when all the testing has completed and everything is fine, then automatically the CI server or some other server will spin up all the virtual machines or Docker containers required for the production environment. So all of this is done automatically based on the IAC file, right? So this is all very nice. Again, the whole idea is end-to-end automation. Everything is automated. Okay, and then as I said, version control is very important because again, you want to make sure that if somebody makes a change to a configuration file, okay, you should know about it. So the configuration file, your IAC configuration file, is going to be maintained in the VCS together with your original source code of your application. Okay, now we have something else called configuration management, which is kind of related to IAC but a bit different. So IAC is really about just the infrastructure itself, which means it's about either the virtual machines, okay, so your EC2 Windows instances are virtual machines, or it's about an actual physical server. Okay, that's what infra is about. But after you set up your servers, whether they are actual physical servers or whether they are virtual machines, you also need to configure them. In the sense, you need to configure what kind of software is going to run on them, and also what port numbers they're going to use, and how do I set up the values for the virtual machines. So as an example, these are examples of configuration data. So like if I'm using a VM, I need to know, okay, when I start up this VM, how much CPU is it going to have? Is it going to have 6 CPUs? Is it going to have 8 CPUs? How much RAM should it have? How much disk space should be allocated to it? Okay, then if I have a database, MySQL, Oracle or DB2, okay, or PostgreSQL, okay, Microsoft SQL Server. So servers all will be accessible on a specific URL. They will be running on a certain port. The server itself will be running on a certain port, the domain name. All these are also configuration. Now, other things is passwords. If you need to connect to your database has some security, you need to configure the password to connect. That is also configuration. So all this is considered configuration data, and you need to have a central location to keep all this configuration data for your entire infra. Okay, and that is the purpose of configuration management. It's going to track and monitor the changes to all the configuration data of all the assets of IT system. So the assets are both software as well as your infra. Okay, and of course the reason why you need to track all these changes is to make sure that the assets are configured correctly, they stay in a consistent state, they perform as they are expected. Okay, and the problem with manual CM, the manual CM means you manually set all these values yourself. So that means when you, let's say you spin up an EC2 instance, you manually at the UI console, you type in, okay, I want 6 CPU, I want 8 GB RAM, I want 32 GB disk space. So you manually type in all these values yourself, and you forget what are the values you type in. So the next time you have to do it, you forget it. You forget what you did, right? Or you tell someone else and they might get the wrong numbers or whatever. So that means if you accidentally do any of those things, that's basically a misconfiguration. That leads to all these bad things: poor performance, inconsistencies, and also many security issues. You don't configure your firewall properly and so on. Okay. Then if there are assets that are actually not configured properly, they are performing too slow, they are not secure enough, whatever, you also need to reconfigure them and so on. If the IT environment is very complex, it's very difficult to do this manually. So just basically doing stuff manually in a complex environment is not possible. Okay, so that is where CM comes in, or automated CM. So you can do things like you can consistently define your asset configuration and data and settings. You can provide a baseline configuration which you apply to multiple assets simultaneously. So you might say, I have a baseline configuration for all my Linux servers. So it doesn't matter whether it's a Red Hat Enterprise Linux, Fedora, CentOS, Ubuntu, Linux, SUSE. It doesn't matter. I'm just going to apply a baseline amount of settings to all these VMs at the same time. And you can do that with automated CM. You can then provision the infra according to the settings. You can monitor the existing VMs that are running, or the existing assets that are running, and check whether they are performing correctly or not, identify any outdated issues, and then you can push out updates to them. So these are all the nice things about CM. So as I mentioned, CM is used together with IAC. So after you have provisioned your infra, you're going to use your CM to configure your infra. So configure your infra would be like we already saw. These are the kind of things you want to configure. So after you have set up your infra, you have already installed your database, you want to configure your database. Okay, what's the URL for your database? What's the domain name for your database? What's the port number that your database server is going to be listening on? What are the passwords I need to use to connect to the virtual machine that your database is running on? What's the password I need to SSH to the database to open a client to the database? Blah, 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 and so on. What's the, how much CPU I need to allocate to the VM? And so on. There are many other configurations. Like if you work with a Docker provider, you have to configure a Docker container. You have to configure where is the location of the volumes, the locations of the hosted drives, and where did you mount the volumes, blah, 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 and so on. All of this has to be there. So this is done during or after the IAC. Okay, after you've done your infra, you've got to have all this up. And again, just like the case of your IAC, which you maintain in the VCS, your configuration data also must be also managed in a VCS. So everything must be managed in a VCS. Your configuration data, your infra data, of course your source code itself, all of these must be centralized and managed in a VCS, okay, so that we can easily revert to a previous working configuration if necessary. So like, let's say I have a IAC and a CM file which provision my infra, configure my infra, and then suddenly my infra is not working. You know, I can revert back to a previous working configuration in my repository if I keep track of it. So this is very important. Okay, you need to make sure everything is centralized and managed in VCS. So here's an example of how you can do use CM to provision your VMs on the cloud. So this is, let's say this is a IBM Cloud or AWS or whatever. So let's say you have already set up all these EC2 instances. Then you might want to do configuration management in the terms of, you might want to set up the SSH key that allows you to connect into all these instances. You might have an inventory of software that you want to install on all these instances at the same time. Terraform is another kind of IAC CM tool. You might use a Terraform file to run. Okay, and this one is actually, this thing is called Ansible, which we are going to look at in the lab. We're going to use an Ansible playbook to actually configure all these VMs once we have spun them out on the cloud. Now, in real life, IAC and CM are both done together. So you don't really have separate tools to do IAC and you don't have separate tools to do CM, because these two activities, they're combined together into one single tool. Okay, and these are some of the more common ones. The most popular one is Ansible, which is what we're going to be using in our lab session. And these are a variety of other alternatives as well. And AWS also has its own tool as well for doing IAC CM, and so does Azure, and so does Google. Okay, so all of these are different IAC and CM tools. Some of them are very specific for specific cases, like Vagrant is very specific for VMs. Okay, so Vagrant is something like Kubernetes for Docker. Okay, so some of them are very technology specific. Vagrant is very like focused only on managing VMs in VirtualBox or VMware Workstation. Okay, others are more generic like Ansible, Chef, and Puppet. So that's a quick overview of IAC and CM in the DevOps world or domain.